Hello everyone. Today we are going to show you how we can. Today we will start a new chapter. Today we will start a new chapter. That is, first of all, we learn about what is the physical quantities and how we deal with physical quantities that are going to deal with this one. You see, what uh, we want to discuss this one, that what is the meaning of physical quantity and how it can be dealt with, right? First of all, we learn the various things uh, in vectors, and we will learn about the physical quantities, that is scalars and vectors. After that, we will do this how to define these quantities, and we learn the various things. First of all, we learn the scalars and vector quantities. You see here how we are defining this one. You see here we are dealing with scalars and vectors. First of all, we learn about physical quantities. What are physical quantities? The first important thing is that physical quantities. First, we learn about physical quantities. What are physical quantities? Physical quantities are those quantities which can be measured, right? For example, length can be measured, mass can be measured, time can be measured. So we can say that these are physical quantities. Or you can say, so these are known as physical quantities. And physical quantities are categorized into two parts. One is scalar quantity, another is vector quantities. Scalar quantities and the other one is vector quantities. Vector quantities. Now you learn, we also know that what are scalar quantities. That scalar quantities is a quantity that has magnitude only. Scalar quantities are those physical quantities which have magnitude only, for example, length, mass, and time. And vector quantities are those physical quantities which have magnitude and direction both, right? For example, the example of vector quantities are force, or you can say weight. These are vector quantities. Acceleration, these are vector quantities. And vector quantities are represented in this way. That is, suppose vector A, we represent this vector A in this way, right? Suppose this is a vector, this is a vector. The length of the line AB says the magnitude of the vector, and the arrow shows the direction of the vectors. In this way, we can represent the vectors, right? So in this way you can represent, or you can represent in this way also. Suppose small a, this is vector A, we can write, or we can write in this way AB, vector A to B. This can be also represented in this way also. This is known as. And if we want to find the magnitude, we say it in modulus. Suppose this is vector AB. This is the modulus of vector AB. What modulus means? Magnitude. Modulus of AB vector. Modulus means what? We can find the magnitude. You can find the magnitude of this vector, right? Now we learn the various things that in vector there are addition of vectors. In vector law there are addition of vector. There are three laws of vector addition. Now we learn about the laws of vector addition. Laws of vector addition. Vector addition. Actually, in law of vector addition, we have three laws of vector addition. Number one is known as triangle law of vector addition. Triangle law of vector addition. This is known as triangle law of vector addition. Number two is known as parallelogram law of vector addition. This is known as parallelogram law of vector addition. Law of vector addition. We learn all these things, all these in detail. And the third one is polygon law of vector addition. These three laws we apply here. Polygon law of vector addition. Law of vector addition. Now we learn all these three laws, how to add what is the formula for these how we apply this vector addition. First of all, we learn about the triangle of vector addition. Triangle of vector addition says that if there is a vector A, if there is another vector B, this is vector A, this is vector B, then the third side of the triangle gives the resultant, or we can say initial point of the first vector and final point of the last vector will give the resultant vector. This is the resultant vector, and this is known as triangle of vector addition. Number one, in triangle of vector addition, we say that vector R or resultant vector equal to vector A plus vector B. That means we'll get the vector A plus vector B. This is the triangle of vector addition. And there is another law, that is parallelogram law of vector addition. Number two is parallelogram law of vector addition. In parallelogram law of vector addition, we will do in this way. Suppose there are two vectors A and B. A vector, this is A vector, and this is B vector. So we replace this B vector here with the same direction and magnitude. And if we make a parallelogram, then the diagonal of the parallelogram is the resultant of the vectors A. Actually, these vectors are the polygon, parallelogram law of vector addition and triangle of vector addition are actually same, right? Here you see, same, you are getting the resultant vector as vector A plus vector B, vector A plus vector B. So in this is the triangle of vector addition. This one, first one is triangle of vector addition. Second one is the parallelogram law of vector addition, right? This is the triangle of vector addition. Triangle law of vector addition. Triangle law of vector addition. Triangle law of vector addition. And the second one is, this one is parallelogram of vector addition. That is vector same, though they are give the same result, that is vector A plus vector B, and we give it as parallelogram law of vector addition. Parallelogram law of vector addition. Law of vector addition. Okay. Besides that, we have another law, that is polygon law of vector addition. That I am also going to discuss how we find the parallelogram of polygon law. So there are more than 2 or 3 vectors. Suppose this is vector A, this is vector B, this is vector C. Then we apply this formula that initial point of the first vector and the final point of the last vector we add, we get the resultant vector. Here you see, right? That means vector R is equal to, in this we can represent here as vector R to 3. Vector R will be equal to vector A plus vector B plus vector C. This is known as polygon law of vector addition. This is known as polygon law of vector addition. Polygon law of vector addition. So we learned that there are 3 types of vector addition. One is known as parallelogram triangle law of vector addition, this one, and the second one is parallelogram law of vector addition, and the third one is polygon law of vector addition. In this we can add. And suppose there is another vector. Suppose this is vector A, this is vector B, this is vector C, and this is vector D. Then we find it here, the resultant vector is 0 according to polygon law of vector addition, because we are starting from A and comes to the same point A, therefore the resultant is 0. Therefore resultant vector is 0 in this case, because the initial point and final point is same, right? In this way you can find the different physical quantities or vector addition. So we learn 3 vector addition. One is triangle law of vector addition, and the second one is parallelogram law of vector addition. Third one is polygon law of vector addition. Again I am telling you that in triangle law of vector addition, if this is one vector, this is another vector, the third side of the triangle is the resultant vector. And in law of parallelogram vectors, if this A vector and B vector, you replace this B vector here with the same direction and magnitude, then the diagonal of this parallelogram gives the resultant vector. Therefore R equal to A plus B. And in polygonal law of vectors, you add all the vectors, that A vector plus B vector plus C vector equal to R vector, right? The initial point of the first vector and terminal point of the last vector, or final point of the last vector gives a resultant in case of polygon law of vector addition, right? These are the various laws of vector addition. Now we learn the general law, how to find the general law of vector addition. Now we learn the subtraction of vectors, how you make the subtraction of vectors. This is the addition of vectors. Now we learn the subtraction of vectors. In subtraction of vectors, you see here, this is subtraction of vector. Subtraction of vectors. In subtraction of vectors, what you do that in this way, you see, or suppose there is two vectors. One is vector A, another is vector B, right? How to add? Suppose this is vector A, right? And there is another vector, suppose this is vector B. This is vector A, this is vector B. You see here, if we add the initial point of the first vector and terminal point of the last vector, we get the resultant A plus B. You see, this vector is the A plus B vector. This is the resultant vector, and we call it as A vector plus B vector. R vector is equal to vector A plus vector B. But we change the direction of B, this B in this direction. This is plus B, therefore this will be, since the direction is changed, it will be minus B vector. And if we add these two vectors, it will be A minus B vector, right? So you can see here it is A minus B, therefore the resultant in this case is vector A minus vector B, vector A minus vector B, right? In this way you can add, or you can say in this way the resultant vector will be vector A plus of minus B vector, and as a whole you get A vector minus B vector. That means if we change the direction of vector B, we get this vector, and the resultant is A minus B vector, right? In this way we subtract. This is the subtraction of vectors. So in this way we do the things, right? And now we learn about one thing, that is vector addition by analytical method. We learn how to this is the generalized method, how we find the vector vector addition of in analytical method, right? In the case of vector addition, we will just going to not derive the result, but we will learn the formula only. You see here what is the formula for vector addition. This is generalized rule, right? Vector addition, vector addition. This is the general rule to find two things. One is known as the resultant, and the other one is the direction. Suppose there are two vectors. This is vector A, this is vector A, this is vector A, and this is vector B, and they make an angle of theta between them. This is angle theta, right? And if we add the two vectors, you see here, if we add according to parallel law of vector addition, here we are making parallelogram. See, we are making the parallelogram. This is B vector. So you can say that the resultant vector is this one. This is the resultant vector, or the diagonal of the parallelogram. This is the resultant vector, right? This is the resultant vector. And this resultant, suppose, makes an angle of alpha with vector A. Suppose it is an angle of alpha with vector A, right? And if we draw a perpendicular line from here, perpendicular line, right? Therefore you can see here that this angle is also theta, and this is 90 degree. This angle is theta degree. So you can find that then parallel law of vector addition, we get this formula, that is number one. One is we get the a resultant vector as resultant vector as capital R equal to R vector equal to A vector plus B vector, right? A vector plus B vector. According to parallelogram law, this is A vector, this is B vector. So this R vector will be vector A plus vector B. We know this one, that the according to parallelogram of vector addition, the diagonal of the parallelogram gives the resultant of the vectors, right? Not only that, we have number 2, second one is the law of cosines. Name is law of cosine. If you know, remember this formula also, law of cosines. In law of cosines, this vector R vector gives R is equal to gives the vector. This is the resultant vector gives in this way, that a square plus b square, a square plus b square plus 2ab cos theta. What is theta? Theta is the angle between vector A and vector B, right? Therefore, this is the law of cosines, right? And if we find angle of R from A, number 3 is this gives the resultant. We want to find the angle of R vector with A vector, then it gives us a formula that tan alpha. If you remember this formula also, tan alpha is equal to b sin theta divided by a plus b cos theta divided by a plus b cos theta. So if you remember these 3-4 formulas, so that you can understand all about the basic things about vectors. So the resultant vector is a vector R vector equal to a vector plus b vector, and law of cosine root over a square plus b square 2r plus 2ab cos theta, and angle of R with a is tan alpha equal to b sin theta divided by a plus b cos theta, right? Besides that, we will get another law, that is law of sines. We are not deriving, but just writing the formula so that you can understand. This R by remember that this is R, this is theta, the opposite angle will be sin theta. R by sin, we are not going to prove this one, we learned these things only. R by sin theta is equal to A by this is A, therefore this angle we take it as beta, therefore A by sin beta, opposite angle will be there. A by sin beta is equal to B by sin alpha. So these 4 laws you have to remember to learn the basic things about vectors. These 4 laws you have to remember, right? So these are the basic things of vector addition. Now we'll deal with this one, this law of cosines and angle with R. Suppose there are 2 vectors. I am taking 3 cases. Suppose one vector is vector A. This is vector A, and this is vector B, and then the same direction, right? And what will happen here? The same direction. That means you see here that theta is equal to 0 degree, right? How we add? We add this in this formula, like here, right? Root over R equal to root over A square plus B square, right? That is A square plus B square. This is a generalized rule, right? And we can add any vector with these 2 formula, right? A square plus B square plus 2 AB cos 0. Cos 0 is 1. That we can write it here as root over A square plus B square plus 2AB. Or you can write it here as root over A plus B whole square. Or you can write vector R is equal to vector A plus vector B. That if they are in the same direction, we will add it according to this formula, right? And according to this, if you want to find the angle tan alpha, or if you want to find the direction, that is tan alpha is equal to B sin 0 degree divided by A plus B cos 0 degree. What is that? B sin 0 is 0. That means 0 divided by a plus cos 0 is 1, a plus b, and that is given as 0. Or you can find as tan alpha is equal to tan 0. Therefore, alpha equal to 0 degree. That means what you are finding, the resultant will be say in the same direction, in this direction of a plus b, right? Therefore, resultant vector will be in the same direction, a plus b vector, right? So we apply this general formula in any vector addition, right? Suppose if there are two vectors in opposite direction, what will happen? Suppose they are in opposite direction. This is a vector, and there is another vector, there will be in opposite direction. How to add this one? You see, what is the angle between them? The angle between them is 180 degree, right? You see, if we find the angle, then it is 180 degree. This is 180 degree, right? Therefore, finding that theta is equal to 180 degree. Okay, now if it is 180 degree, then we find the formula here, r equal to root over a square plus b square plus 2ab cos 180 degree. And what is the value of cos 180? That is minus 1. Cos of 180 degree is equal to, you can find it in this way, cos of 90 degree plus 90 into 2 minus 0 degree, right? Here cos is there, therefore cos 0 is there, will be there, cos 0 degree. And you see here that in the second quadrant cos is negative, right? We know that all sine, tan, cos, all sine in second quadrant sine is positive, all sine at tan and cos. In second quadrant cos is negative, therefore minus cos 0, therefore the value is minus 1, right? Therefore we are getting the value here as a square plus b square minus 2ab, or we are getting the value as a minus b whole square, right? Therefore in this case the resultant we are getting here as vector a minus vector b. So always we'll apply this formula to find the addition of vectors. That if they are in the same direction, we'll add the vectors. If they are in the opposite direction, we'll subtract the vectors. Suppose there is another one, that is, suppose we want to take another. This is case 1, case 2. We are taking they are in the same direction. Here you see they are in the same direction. We have taken it as the same direction. This is case 1. Case 2, this one, if they are in opposite direction, then this will happen, right? And not only that, if you want to find the case 3, that is in another, that is case 3, suppose this one, we are taking another example or another case, that is suppose we are taking case 3. If they are perpendicular to each other, then what will the resultant be? That also we can find here, right? You see, we are going to case 3 and we find what is the resultant of this vector. You see here, if they are this one, if they are perpendicular to each other, then what will happen? Suppose there is two vectors, case 3 is case 3. Suppose there are two vectors, vector A and vector B, and you see there vector A and vector B has 90 degree, the angle between them. Therefore, we find here that theta is equal to 90 degree. What will be the resultant? In the same way, resultant will be root over of this one, that is a square plus b square plus 2ab cos 90. And you know that the value of cos 90 is 0. Therefore, writing r equal to root over of a square plus b square, root over of a square plus b square. You see here, if we add these two vectors, and this is again 90 degree, then this one gives the resultant, this vector, r vector, right? Therefore, we are getting the vector as r equal to root over a square plus b square. This is the resultant, right? I mean, in case of 90 degree, we are getting the value r equal to root over a square plus b square, and the direction will get find tan alpha, and that this is the resultant. And we find the tan alpha, the angle, what is the angle with vector A, then it is same as b sine 90 degree. by a plus b plus b cos 90 degree. Sin value of cos sin 90 is 1, therefore it is b by a. Therefore the alpha will be tan inverse of b by a. So we can find any value with any addition of vectors with this formula only, that is law of cosine r equal to a square plus b square. That is, if they are in the if they are in the same line, same direction, then they will be added. That is vector a plus b. In case of same direction, vector r equal to vector a plus vector b. If they are in opposite direction, the resultant will be vector a minus vector b. And if they are at 90 degree, vector r will be root over a square plus b square, root over a square plus b square, right? And the angle between them is tan inverse of b by a. These three cases we have dealt. But suppose there is a angle between 60 degree, then you have to apply this formula, right? Only then you get the resultant of these vectors in this way. If you want to find any angle, suppose the angle between a and b is 60 degree, then you have to put the value of theta as 60 degree, and you will find all these values also, right? In this way you can find the addition of two vectors, right? Now we find these are the find what we find law of cosines and law of sines. Like law of sine also you know, law of cosine you also know, and how to find the vector addition, that you have also know. And addition, we have learned about three addition of vector. One is addition of triangle law of vector addition, number 2 is parallelogram law of vector addition, and number 3 is polygon law of vector addition. And besides that, we have learned this one also, that law of cosine r equal to a square plus b square plus 2ab cos theta, and tan alpha is equal to b sin theta divided by a plus b cos theta. In this way, you can find any addition of two vectors, right? Now we'll find some other vectors also, equality of vectors. Now some will define some vectors or some types of vectors. Now we have different types of vectors. So I have very different types of vectors. We'll learn a few of them because there are many types of vectors we have. First we'll learn about the equal vectors. Equal vectors. How we find equal vectors? Equal vectors are those vectors. Equal vectors are those vectors which are equal in magnitude and same, and equal in magnitude and same in direction also. Suppose there is a vector A and there is a vector B. If the magnitude of vector A is equal to magnitude of vector B, and direction of A and B is same, therefore they are equal vectors. And direction, the magnitude and direction should be shown. The direction of vector A and vector B are same, then they are known as equal vectors. They are equal vectors. They are equal vectors. They are equal vectors. This is known as equal vectors. Sometimes we multiply a vector with any number. Suppose number 2. We can multiply a vector by real number. Multiplication of vector. Multiplication of vectors by real numbers, or vectors by real numbers. Suppose there is a vector A. This is vector A, and you multiply it with this on lambda vector, then this will be lambda times of a vector, right? And where lambda is greater than 0. Lambda is here greater than 0. If you multiply this vector by minus lambda, it will be in this way. The direction will change. This will be minus lambda A. This is how I represent multiplication vectors by real numbers. Now we have to follow the relation property of vector addition. This is the property of vector addition. These are the properties of vector addition. We have two properties of vector in case of addition, right? Number one is that vector addition is commutative. Number one property is vector addition is commutative. Vector addition is commutative. Vector addition is commutative. If vector addition is commutative, means vector A plus vector B is equal to vector B plus vector A. And number two is that vector addition is associative also. Vector addition is associative. These two laws you have to know. First one, you can say that vector A plus B in bracket, vector A plus vector B plus vector C is equal to vector A plus vector B plus C in bracket. So we can say that in properties of vector addition, that vector addition is commutative and vector addition is associative also, right? But in case of this subtraction, it doesn't follow. Properties of vector subtraction, properties of vector subtraction, these two law doesn't follow. Subtraction, number one, that vector subtraction doesn't follow commutative law, does not follow commutative law, does not follow commutative law. That means you can say that A vector minus B vector is not equal to B vector minus A vector. These are not equal. And number two is that vector subtraction does not follow associative law. That means A minus B vector minus C vector does not follow, not equal to A vector minus B vector minus C vector. So in case of subtraction, these commutative and associative law doesn't follow in vector subtraction, but in case of properties of vector addition, it follows vector addition, that is vector addition is commutative and vector addition is associative also, right? These are the few things, and the other important vectors we learned about is that about these we have learned. Equal vectors, if the two vectors are equal in magnitude and direction, they are equal. And multiplication of vector by real numbers, you can multiply this number. There are other types of vectors also. Suppose another vector is known as zero vector or null vector. This is null or zero vector. Null or zero vector. How can we find null and zero vector? That is, when you add a vector plus of minus a vector, then it comes to zero vector. And remember, the modulus of 0 is always 0. The modulus of 0 is always 0. Since the magnitude of null vector is 0, its direction cannot be specified. So you can say, since the magnitude of a null vector, magnitude of null vector is 0, its direction cannot be specified. Its direction cannot be specified, cannot be specified. Its direction cannot be specified, right? So what are the basic things in null vector? That we can say that vector A plus 0 is equal to we got the vector A. And number 2 is if we multiply 0 vector with lambda, we got the 0. And third thing we can say that 0 into a vector is always 0. So these three factors we are going in case of null or 0 vectors, right? Besides that, we have other type of vector also we can say, that is unit vector. What is that unit vector? Unit vector can be said in this way that unit vectors. Now the important thing is unit vectors. Unit vector. This is very much important for us. Unit vectors. What are the unit vectors? Unit vectors are those vectors which are the magnitude of 1, and it is used to specify a direction only. What is the definition of unit vectors? The definition of unit vector is n unit is equal to vector A by modulus of vector A. This is the definition of unit vectors. Or you can say unit vector is a vector of unit magnitude. Its magnitude is 1 and points in a particular direction. It has no dimension in unit. It is used to specify a direction only. It has no dimension and unit. It is used to specify a direction only, and it is represented as n unit a vector by modulus of a vector, right? And n unit vector is along vector A. That is the direction is vector along the vector A direction. That is known as unit vectors. Besides that, there are other types of vectors also. What we can say that the next one is what we can say is that of other vectors. So we can explain, that is coplanar vectors. Coplanar vectors. Coplanar vectors. Coplanars are the vectors which have in the same plane. Suppose this is a plane of paper, and the three vectors are represented here: a vector, or b vector, or c vector. That is, they are in the same plane, and so a, b, c are coplanar vectors. Coplanar vectors means that the vectors are in the same plane. That is, they are known as coplanar vectors. So these are the important types of vectors we should know, and we learn the main themes of vector addition and vector subtraction, different types of vectors, and these are the scalars and products, right? And now in the next session we learn the position and displacement vector. These two vectors we learn in the next session. So in this way you can learn the various things of coplanar vectors, right? This is coplanar vectors and this is unit vectors. That means those vectors which are in the same plane are known as coplanar vectors. So we learn about the various addition and subtraction of vectors, right? Besides there is multiplication of vector also, that I am going to learn, that is multiplication of vectors. Multiplication of vector. Multiplication of vectors. Actually, there are two types of multiplication in vectors. One is known as scalar or dot product. Scalar product or dot product. Scalar product or dot product of vectors. Dot product of vectors. How to represent? Suppose there are two vectors, a vector dot b vector, a vector dot b vector. Then we find it by the formula a modulus of b into cos theta. This is the formula for dot product. There is another formula, that is scalar cross product or vector product or vector product, cross product or vector product. Here you can say that in scalar product or dot product you can find the value of angle between A and B vector, right? If A and B are given, you can find the angle between them, right? A modulus of A modulus B into cos theta. And the examples of scalar product is work done. Work done, we know that is a scalar quantity and the formula is F dot S. F dot S, where F is the displacement force and S is the displacement. And if we multiply it, then work is a scalar quantity. Work is a scalar quantity. Work is a scalar quantity. A scalar quantity. Right? And there is another vector product or cross product. If we cross these vectors, A vector cross B vector, then we find the value as modulus of A modulus of B vector into sin theta into n unit vectors. Or you can find the A cross B in determinant form also, right? In determinant form also we can find the value of A. Suppose there is two vectors. A vector is given as 2i cap plus 3j plus 5k, and B vector is represented as 3i plus 5j plus 2k. Then you can find A cross B in the form of determinant also. We can find the determinant of A cross B in determinant method. And determinant is with I vector, this is J vector, this is K vector. And determinant method is like this, that is 2, 3 and 5. It is 3, 5 and 2. We can find the determinant. We know that how to find the determinant. First we will take the I vector and you have to take in this multiplication. This is the first multiply and this is the second multiplication. How? If whenever we are taking I, leave this row and this column and you multiply this one, that is 2 into 3 6 minus 5 into 5 25 plus j. When you take j, you have to take this is the first multiplication, this is the first and this is the second. This is the second multiplication. First one is this one. That means where j, leave this row and this column. That is, first you have to take this one. This is the first. This column, the 3 into 5, 15 minus 3 by 15 minus 2 is 4 plus k. K is same. K is again, this is first, this is second. You have to leave this row and this column. That is 5 is 10 minus 9. Then we are getting 6 minus 25, that is minus, we are getting a value of minus 6 minus 25, that is we are getting minus 19i plus 11j plus k. So this is the resultant of vector A cross B. So for finding A cross B, find a determinant value. For scalar product, modulus of A modulus B into cos theta. These are the scalar product or dot product of vectors. And in cross product, you know that tau vector can be found out in this way: r cross F vector, r vector cross F vector. You know this one, that tau equal to r cross F, right? R is the perpendicular distance, F is the force, and tau is the torque. You know this one. So for scalar product, work done is very defined, and for cross product, torque or tau is given r cross F. These two relations, if we remember, we should nearly complete all the addition of vectors, addition and subtraction, and vector multiplication and types of vectors. So the most important thing is unit vectors, and the next day will deal with unit vectors also, right? In this way, we have almost completed the vectors, and the next video we will learn other things of vectors, that is relative velocity, and there are other factors also that we are going to discuss in the next session. Thank you everybody for watching this video. Thank you.